Hello and welcome. Today we're going to take a look at the case The 24 Hours of Le MEWC by Vincent Moran. His first case in the official list of cases, and this one is in the main event. Let's take a look at the instructions. The 24 Hours of Le MEWC is an iconic endurance motor race featuring 60 teams of 3 drivers competing under 3 different categories: prototype, pro, and amateur. As the analyst for Team FMWC, one of the teams to have entered the prototype category, your role is to provide analytical insights about the drivers and their teams in order to optimize your team's strategy and hopefully bring home the trophy. All right. Auto racing is one of my favorite things, although I've never watched the 24 Hours of Le Mans. But I'm really excited about this case. Let me show you what else we've got in here. So we've got this nice long drivers table. We got drivers' names, their teams, the categories, a bunch of statistics about them. We also have a map of the track. Now, this is very interesting because when you see a map, one of the first things you think of is, oh, this is a map case. But actually, it's not. And I'll try to remember to talk more about that at the end of the video. But yeah, that's what this case is all about. Let's go ahead and get started. Let's see how long it can take to get a full solve. And here we go. Level 1. For each given driver, what is the sum of their 5 attributes? Steering, braking, acceleration, endurance, and nighttime driving. So what I'm going to do is I'm going to turn this into a proper table here. We're going to call this driver. And then instead here, let's do number. So let's write number. Number, name, team, category, steering. Yep, that looks all good. So to get this, what I'm going to do is I'm going to XLOOKUP this in driver name and return all 5 of these categories. So one of the beautiful things about XLOOKUP is you can return more than one column from a table. I got 5 columns here. I just need to sum these together, and that should give me my answer for this level. Very good. Level 2. For each of the riders below, which of their attributes has the highest value? All right, so I'm going to start the same way that I just started with the last one. So I'm going to look up that in driver name and return these 5 columns here. And then what I'm going to do is I'm going to do another XLOOKUP. So I'm going to look up the maximum of those numbers. Let's see. Sorry, we need to close that max. In that list, and then return the 4 headers: steering, braking, acceleration, endurance, nighttime driving, just like that. Now, if I did that right, that should give me the right answer there. Now, the one thing that always worries me about tables is you can't lock cells within a table, so I don't know if this is going to fill properly. It did. I'm happy. Let's go to level 3. What is the average of the given attributes for the 3 drivers from the given teams? Round your answer to the nearest whole number. All right, so we have a Team FMWC. We look at our list, so we see there are 3 drivers for that, and we're going to look at the attribute of steering. So what I want to do is I'm going to filter. Let's start by filtering those 5 attributes where the team name matches the name on this sheet. So I should have a list of 15 numbers. I do. And then I'm going to take whichever column steering is in. So let's do index. That array, row number is going to be 0, and column number is going to be matching that steering there to the 5 columns here. Now, if I did that properly, I should be left with 3 numbers, which I am. I am going to average them, and then when we average, one thing we got to be careful is how we're going to round. Yep, that's a long number. Round your answer to the nearest whole number. So let's go ahead and round that by 0. Excellent. Let's bring that over here. And there we have it. There we go. All right, level 4, driver's base speed. A driver's base speed at a given moment is a function of 2 factors: the phase of the track, steering, braking, acceleration, and the driver's corresponding attributes, steering, braking, acceleration, respectively. Each phase has a base time per cell, which is reduced based on the driver's skill level for that phase. The reduction is applied linearly according to the formula equals base time plus attribute point times reduction rate. Note, reduction rates are expressed as negative numbers in the support table. Adding a negative number will decrease the base time, resulting in a faster cell traversal. How many seconds would it take the driver to go through 100 cells, each belonging to the same track phrase? Ooh, nice long set of instructions. All right, so Let's do a new sheet for this. We'll call this level 4 there. Let's bring in all the key information. So bring in all of that. Set up my data table runner. There we go. Okay, and then let me widen these so I can see what's in that table. Excellent. All right, so let's bring Lorenzo's 5 attributes out. So we're going to go these 5 attributes. We're going to XLOOKUP this driver name, return these 5 attributes. There we go. And then let's also bring out, we don't need the number of cells yet, actually, no. So we have 3 types of cells. We have steering, braking, and acceleration. So let's do, oh, you know, I could just do it right under here, couldn't I? Yes, I could. All right, so steering is 6 seconds minus 0.03 seconds per point. So go to 6 minus 0.03 times that. Excellent. We're gonna do 4 minus 0.02 times braking. And then for acceleration, we're going to do 2 minus 0.01 times acceleration. All right, so that should be the distance per cell. That's asking how long does it take to drive through 100 cells? Multiply that by 100, so we have these numbers here. The last thing I need to do is I need to make sure I'm pulling up the right one. So I'm going to XLOOKUP the track phrase against these 3 and return these 3 numbers here. All right, I get 202. Excellent. Let's bring these question numbers in. Very good, very good. Okay, we're doing fast, we're doing good. All right, level 5. Drivers slow down because of endurance loss and time conditions. However, high endurance or nighttime driving attribute points reduce these slowdowns, making the driver less affected by fatigue or darkness. Each modifier represents a percentage increase in lap time, i.e. a slowdown. Higher attribute hours make this slowdown smaller. Apply all the modifications multiplicatively, see example 5. Based on the information from level 4, this level has the same set of driver track phase, the time of day, and each driver's attributes. How many seconds would it take the riders to drive through 100 cells, each belonging to the same track phase? Round your answer to the nearest second. All right, now I'm gonna have to take my time on this because, to be honest, when I did the live solve, this is the part that really was tricky. I'm going to continue off of my level 4 model. I'm going to copy these. I'm going to put these in the same spot as they were before. Right, okay, I got to do my runner again. So, G.I now. Okay. And then what we need, I want to bring that table over as well. Let's bring that table. Let's put that table here. Oh, that needs to be widened quite a bit, doesn't it? Still needs to be widened. Are you crazy? Still needs to be widened. Got those in. Let's reduce that a little bit. Try to save a bit of space. And then let me bring the example calculations. I think that should cover it all. Let's see. Yeah, okay. All right. So we have a time of day, we have a track phase, we have a driver. So we have endurance, nighttime driving. So we need an endurance effect. And the endurance effect is going to go here. So let me take very care. I'm going to try to follow what we have here, but then write it in here. So it is equals, oh, we need to get the percent. We need to get the percent from the date of time. The way I'm going to do that, excuse me, is, let me just see. So I'm going to do 1, 2, 3, 4. Whoa, that's interesting. Not what I expected there, but that's okay. So let's do time period. And what I want to do is I want to find out whether it's one of those 4 time periods. So there's going to be a whole bunch of if statements. So if and that is greater than 4 p.m., so 16 over 4, and this is less than 10 p.m., so 22 over 24. I'm also going to add the equal sign here. I don't know if the equal sign actually matters because it doesn't say whether we start exactly at 4 or end exactly at 10, but I'm going to do the start there. So if it does match both of those, then we're in time phase 1. If it doesn't, if it matches either, let's see, I-30 is greater than or equals to 10 p.m. or I-30 is less than 4 a.m. So you see what I'm doing is I'm taking the hours out of 24 and dividing it by 24. That's how hours are calculated into Excel. Then we are in time phase 2. If the time is, I30 is the time, right? Greater or equal than 4 out of 24. I30 is less than 10 out of 24, so that's 10 a.m. Then we're in time phase 3. And I could put just 4 there, but I'm going to play it safe. If and I30 is greater than or equal to 10 a.m., but I30 is also less than 4 p.m. Yes, then it should be 4. Otherwise, we'll leave it blank, and then we'll jump off that bridge when we get to it. All right, so 11:55 is time period 2. That is correct. Excellent. So let's get this formula. So endurance is 5%. So 5% is looked up from this table here. So we're going to index these periods, and we're going to take that one. So that's going to give me time period 2. That's going to give me 5%. Excellent. Times, in parentheses, 1 plus, in parentheses, their endurance factor, times, and it's minus 0.1%. So negative 0.1%, double close. Oh, I need to close the index. That's why I'm missing a bracket there. Triple close. If this all is right, then I should get 4.60%. I do. Okay, excellent, excellent. Oh, that makes me happy. That makes me very happy when things actually work out for the first time. I want to fill this over, so let me just change a few things. I want to make that unlock, that lock. The rest should work the same, because I believe if I do that, 19.26. Yes, the formula is just about the same. Second row, pull that out. This part is the same between the two. That is good. So whatever number we get here is going to be affected by those two. So base speed of 2.02 times 1 plus 46% times 1 plus that percent. So it's going to be these times 1 plus this percent times 1 plus that percent there. All right, do I need to round? I don't round yet. I round when I take the 100 cells. Is that 100 cells? That is 100 cells. Probably should do that. Should probably do that with 1 cell. And then X look up the track phase against these 3, return those 3, and then multiply that by 100 there. Ooh. Ooh. No. Blue bar should be here. There we go. Okay. Round that to 0 digits. These numbers are different. We're starting with number 81 now. Excellent. See if these line up. Awesome. All right. Level 6. Sorry, I got a bit of a cough today. Based on the information from levels 4 and 5, what is the given driver's lap time in seconds for the given time of day? The track is available on the track sheet. Round your answers to the nearest second. So here we have the driver, we have the time of day. I think we can continue keeping this model. Probably don't need to copy a sheet every time, but I am, what's the word? Scared of messing everything up. So let's go ahead and copy this over. That's going to be my new runner. We don't need that anymore, but we do need this, and oh, I broke it. Remember what I said about afraid of breaking things? All right, so I30 needs to be H30. Okay, so let's copy this, paste it every time I see red numbers. Now can I delete that, or is that still gonna break it? It shouldn't break it now, right? No, okay, we are good. All right, so this is all good. We just need to get the number of cells for the track, which I believe we can get on this track sheet. So you know how I said that this isn't really a map case? I'm not doing any map techniques on this. The important information is in this table right there. Steering 15, braking 7, acceleration 33. That all lines up. Now I'm going to do these numbers times these numbers. And then this is the total that I'm going to do. I need to round? I do believe. Right, level 6 seconds, round to the nearest second. So I'm going to round that to the nearest second. Take this data table away and just put my data table right in there. Whoops. Oh, that's not good. Oh, I didn't put my runner in. Good job, Ben. BB, case, GH. There we go. Awesome. Now they're all different. Very good, very good. Do I have any more data tables up there? Okay, I deleted them all. Good. Level 7, it's race day. You now have to calculate each team's total number of laps over the 24-hour race. Each driver completes laps continuously, and that driver switches occur instantly at the start-finish line, but only after the current driver has completed the current lap. Each shift is normally 2 hours, meaning a driver hands over the car once they finish a lap. That begin their 2-hour window ends. As a result, driver changes may happen slightly after the 2-hour marks, for example 2:02, 4:03, etc., with those extra seconds already counting down towards the next driver's nominal 2-hour window. However, penalties for endurance and nighttime driving are calculated based on the scheduled 2-hour marks, i.e. 4 p.m., 6 p.m., 8 p.m., 10 p.m., etc. Drivers rotate based on their driver number. The lowest number goes first, followed by the middle number, followed by the highest number before repeating. The process should repeat 4 times, and the highest driver number shall be driving on the final lap. Any lap that starts before the 24-hour mark can be completed and counted even if it finishes slightly after the official race duration. What is the total number of laps completed by each team over the race's duration? Gotcha. 24-hour race, 2-hour gaps. Drivers are going to switch in and out. Got it. All right, so let's do level 7 there. Bring this over to that sheet, and I'm going to do my runner here. That's Team FMWC. Now, the first thing I need to do is I need to get the drivers for Team FMWC. I believe this table is already sorted. It appears that it is already sorted, which is good. So all I need to do then is filter the driver name where the driver team equals this team listed there. So I should get 3 drivers, 1, 2, 3. Excellent. So 24-hour race, each driver changes after a 2-hour window. So that means we're going to have 12 shifts. So shift sequence 12. Let's do driver. And so because the driver is just going to cycle through this list, we're going to index that list. Yeah, we can do that. Mod this over -1, 3 drivers. So we put 3 for the divisor, +1 on the outside. That should cycle through them. It does very nicely. All right. Next thing after we get the driver, we want the start time. So the start time is going to be 4 o'clock p.m. for Lorenzo early, but it's going to change on the other drivers depending on how long it takes Lorenzo to complete his laps. So let's get these factors over. And we are going to XLOOKUP that in the driver's array, return these 5. There we go. And then we need to get the percentages, which are these 2 here. Oh no, we need to get the steering cell, braking cell, acceleration cell. Right. So let's do that and cell. And let me just, what happens if I just try to copy and paste? I'll probably have to change a few things, and that's okay. Yeah, okay. That's easy enough. And acceleration. All right, good. And then what's the last things I need to get? Oh, these 2 effects. Right, now this one's going to be probably a little bit trickier. So let's try once again to copy the formulas. So this is, oh, I need to get the time. I need to get the time window. That's the time window. Okay. So let's do time window. Now, am I doing really bad things? Probably. Oh, that actually worked. That actually lined up beautifully. I would never expect that to happen. Okay, sorry. All right. So this reference should go back to this reference list there. Let's go ahead and lock. I need that reference. I'm working on a different sheet. All right, keep that there. And this J30 is going to be time window here. And then 1 plus, so endurance is based on here. Let's see here. So index N3 to N6. Yeah. kidding me? What's... Oh, right. Endurance. Duh. The race just started. He doesn't have endurance issues yet. Okay. And this should all line up nicely, which it does, but it still gives me a ref error. Why? Right. This should be on time window. There we go. Okay. So no effects yet because the race just started. That makes sense. Let's see. Let's see these time. So it's going to be these three numbers times the three numbers on the track, and they're in the same order, so that should work out nicely there. That is a lot more because it's not those three numbers on the left, it is these three numbers. And actually, you know what I think we could do? I think we just call this lap time. And I think we could just sum this all together. Right, let's call that base lap. And let's call this post effects. And the effects are going to be that times 1 plus your endurance effect times 1 plus your nighttime driving effect. This first driver, it won't matter. Alright, good. Alright, so now let's do number of laps. And this is where it's going to get fun. Add up here. Target time. Oops, not 2 minutes. 2 hours. There we go. All right, so your number of laps. So you need to find out how many laps you can do within 2 hours. So we are going to take those 2 hours. So this minus. I know this is going to change because it start. Well, actually, no, that might be okay. Okay. Right. Take that divided by. This is the number of seconds, so we need to. No, we need it. We can turn this into seconds. So that is the number of days times 24 hours times 60 minutes times 60 seconds divided by the number of seconds here. Let's turn that into a number. 32.34. That looks like it's matching. We need to round up because they can complete the lap. And then we get end time. So, right. So we need to take lap time times the number of laps. So that's the number of total seconds that you took to get around the track. We need to turn that back into hours. So 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. Plus the start time. So 6:02 p.m. Good. And then the next driver is going to start at 6:02 p.m. I think everything else should work. Target time. So that's going to be this plus time, 2 hours, or 2 minutes because I forgot I didn't do that right again. All right. Let's see if these all fill in nicely. Okay. So far so good. Do the next row. Okay. Let's just fill it all down. Of course, the moment I fill it all down, it is no longer happy with me. Right. So I think I know the problem here. I think I actually know the problem right off the bat. This should probably be this should also be plus 1. Yeah, 1.083. That should be 1.000. Nice little, excuse me. All right, so base lap. This is not calculating. Why are you not calculating? Oh, because the track numbers are not locked in. Number 1 rule of Excel competitions: always make sure you lock in your track numbers. All right, now, how many laps do we have total? 325. We should have 344. Oh boy. This start time, this is 2 o'clock a.m. That says 2 o'clock a.m. Why is that so nice and round? Is that supposed to be so nice and round? Let's take a look here. So we should have, first person gets 33 laps, good. Next person gets 32 laps, good. I don't think it talks about the third person, but after that we should be 26, 25, 30. Ooh. Let's do let's add a column in here. Actually, wait, let me just actually, you know what, let me just see something here. So that is yep. I'm wondering if what's happening is something around like this day turnover, but no, that looks like it's all working properly. Oh, something's wrong here. They should not all have this nighttime effect. What's happening here? Yeah. Oh, I see what it is. Okay. Right. Now, there's an easy way, there's a hard way to fix this. I'm going to fix this the easy way. So this is 6 hours. Each driver gets 2 hours, so that should be 6. These 3 drivers together is 6. So I'm going to, again, easy way. 1, 1, 1, that's the first shift. 2, 2, 2, that's the second shift. 3, 3, 3, that's the third shift. 4, 4, 4, that's the fourth shift. Now I get numbers that match. Let's run the data table. The hard way, by the way, was just going to figure out how to change that entire formula to account for a day change. I didn't want to do that. Numbers check out. Let's go to the bonuses. Bonus A, how many drivers have at least 2 attributes above or equal to 80? All right, so we go to this driver tab. I'm going to call this B1. I'm going to count if this is above or equal to 80. And let's say, how what does it say? At least 2, right? Oh, right. Okay. Yeah, comma. The counting function works that way. And we're going to say above or equal to 2. Let's turn these into numbers. And we are just going to sum that column. There we go. Bonus B. You were provided a French language version of the schedule that shows the start of the time of the race is 16 hours 0. How many seconds will have elapsed since the race time start when the time is 21 hours 23? So basically we're looking at 21:23. We're going to look at 1600. The difference in time is going to be that. We need to turn that into seconds. So that's the number of days. We need to multiply by 24 to hours, 24 to 60, 60 gets seconds. That's going to give us 0, but that's because it's not formatted as a number. That is formatted as number 19380. Excellent. Bonus C, find a team that has the smallest sum of the 15 attributes of its drivers. 5 attributes times 3 drivers. What is this number equal to? All right, so what I'm going to do for bonus 3 is I'm just going to sum all of the 5 attributes. And I'm going to do a nice group by, my favorite function, to find out who's got which team has the smallest of those. Looks like this team does at 487. The question was, what is the number? 487 is that number. Bonus D, how many drivers have a lifetime faster than Lorenzo early at 11:55 p.m.? This is related to bonus 6. Let's go take a look at bonus 6. We have Lorenzo early, 11:55 p.m. His lap time is that. Yes, okay. So I'm going to turn this, instead of data table by question, I'm going to do a data table by driver. Lorenzo early is number 1, so I'm just going to not paste him again. Whoops. Run that data table. Oh, I need to copy and paste these because the data table is going to run off of this cell. So we're going to see all of those, and we're going to count if how many of those is faster or shorter than Lorenzo early there. I get 7. Excellent. Bonus E, how many pro teams will complete more laps than the lowest ranked prototype team over the course of the race? All right, so I'm going to do basically the same thing. Let me delete this data table, and I'm going to go to level 7, where instead of doing this by question, I'm going to once again do it by race team. So I'm going to use the unique over the team because all the teams are named 3 times. And then, right, so I need to copy and paste that as a value. Run that through a data table again, based off of this cell now. So now we get how many laps each team completes. Now the question is how many pro teams, so I need to figure out which type of car they're running. So we are going to look up the team names against this driver table, return their categories. So there we go. So we're looking at the lowest ranked team has the smallest number of laps. So we need to see which teams have fewer than, we need to see which pro teams have fewer than 344 laps. So we're going to do count ifs if that is pro, and this is lower than, come on, Excel, let me finish. Don't let my cough interrupt my formula. Wow, that's 20? Does that sound about right? No, it does not. All right, let's take a look here. Let's take a look here. Let's take a look here. They all seem to be lower, don't they? Okay. So let's just see here. This is all less than 344. They are all less than 344. Why do I have a feeling? Oh, over the lowest ranked prototype team. So it's not over that prototype team. Right. Okay, so min ifs. This, where this is prototype. Right. So 273. So how many of those is less than 273? 10. There we go. I would have had a solve in under 30 minutes if I had not screwed up that last bonus question. All right. Well, a very fun case. Now, there's two things I want to talk about this case. First one, I've already mentioned it before. In the introduction video, you see this map of the racetrack. The first thing that you would think of is it's a map case. But you notice that I did not use any of my mapping techniques with this case. I didn't calculate distance. I didn't do a flat map of this map, because the key information for this map is right up here. So I don't need to like try to identify any of these cells or anything. I just need to use these numbers. Now, the second thing that I want to point out is I want to go to level 7. And there's one instruction on level 7 that I'm curious about. And that is this line. Actually, let's say these two lines. Each shift is normally 2 hours. As a result, driver changes may happen slightly after the 2 hour marks, with those extra seconds already counting towards the next driver's nominal 2 hour window. However, penalties for endurance and nighttime driving are calculated based on the scheduled 2 hour marks. Now, when I'm reading this, what I am thinking is that the penalties will start exactly at 6 o'clock p.m. or exactly at 8 o'clock p.m. But you will notice in my model that the way that I calculated it is I didn't find the times at exactly a certain amount of time. I just did the penalties by shift, let's say. So I'm really curious about these instructions. I wonder if either A, the effect is so minimal that it doesn't have an effect on the overall results, or B, maybe I'm misunderstanding the question, misinterpreting the question, or worst case scenario, maybe C is that the answers didn't take this into account. Basically, they took it into account when the driver started their shift. Now, looking here, I'm noticing these two shifts are starting directly on the hour. These two shifts are starting 1 minute after the hour, 2 after the hour. So I mean, really, maybe it is just that small that it didn't have much of an effect on the overall case. But otherwise, that is my solve for the 24 Hours of Le MEWC. I hope you enjoyed watching this video. If you do, be sure to give me a like and a subscribe. I really appreciate that. I hope my videos are helping you learn more so that you can become better competitors yourself. Take care. Thanks for watching, and I look forward to seeing you for the next video.
It's the Excel.